Hello. Uh, Hope you're doing good. So I want to discuss about my specialization project, which was about a process tank simulator, and this simulator should have, capability of switching between the different communication protocols used in automation and different IT industries as well, especially automation and IoT industries. So the core idea over here was to firstly develop a HMI in which this widget can be considered as a tank, and over here we have like different input parameters like Q in, flow rate. We can adjust the flow rate, and this tank has some fixed value of tank height, width, and depth, and we can also change the row, but I also fixed it. But we can change it as well because I considered it as a parameter. And over here we have CV. CV is the flow out valve coefficient. And if any user over here, the thing is we have different communication protocols used in the automation industries. And these communication protocols are like a way of talking with the different vendors' devices. So they provide a common functionality, a common method to talk to different vendor manufactured devices. So this HMI, what it does, like if any user is connected with this HMI through web, and that user can change the value of Q in valve, Q in flow rate in. You can change the value of density as well, Q out as well. So on the basis of that, the fluid height value in this tank will change. And he can also select any of the protocol, like he wants to switch from one protocol, IO protocol to another one. And over here we have implemented three. It's MODBUS, MQTT, and OPC-UA. So like they differ in their architecture, so I will discuss in the upcoming time. Okay, so for this CDP Studio is in IDE, which can be used for like purely software tasks and can be used for automation engineering tasks as well. So it is like providing services for both. So in automation engineering, we can build logic by these build block diagrams as well. So these block diagrams contain the functionality. Like you can implement the logic over here. And for this process tank simulator, I have implemented a simple C++ program, which will be which will be taking parameters from the user, and on the basis of that, it will be calculating, giving out the signals, fluid height, Q out, tank volume, tank area, and P1 at any particular time. So in the CDP Studio, you can create your own custom blocks. So it was a custom block, and otherwise they also provide some already made resources block, which are mostly used in automation domain. So for this, a simple code block was generated, and like how to create it, you can simply create a CDP component code block, component model. Yeah. And firstly, this process tank simulator component model was created, and to implement it for three IO protocols, we have implemented a new library, which was named Process Tank Simulator Library. And in this new library, we just created a tank interface component. And this tank interface components has three IO servers. So for OPC-UA, one OPC-UA server was added, and from this resource panel. And if we want to have MQTT and MODBUS IO functionality as well, so we have to add MQTT client and Modbus slave TCP as well. So what does OPC-UA server does? Like it provides the information to any client he is connected to. So how the information over here goes on. The OPC-UA server contains server object nodes, and these nodes are like hierarchical nodes, and these server object nodes also contain server variable nodes. So for the process flow tank simulator, we have some of the parameters and inputs, and some of the parameters or some of the signals and as outputs. So on the basis of that, over here some server object nodes different server variable nodes were added, and they contain, like, some of them are input, some of them are output, on the basis of the, like, if any user wants to uh, add value to the server variable node, the server variable node will be reading it. And if if any user or any client wants to have the value from the server object node variables, so it will be like he will be reading it from this server object node variables. Okay, and for this, for server OPC-UA server, we have added server object node, and this object node contains different nodes as well. And how to differentiate the nodes? Over here, there is a method in OPC-UA, so you can differentiate them from on the basis of the ID type, like they have different ID, and namespace index we can use 1 or 2, and 0 is reserved, and also this ID we can identify it, like we can give it any name. So on the basis of that, this ID was generated, and after that. This server object node has the routing with the IO port. IO port, what it does, CDP port, what it does, like it takes in different values and takes out the whole values as a I'm gonna say, like so it can takes out the whole object CDP. It bulk connects a list of values. So the CDP port has a list of connections which are used to make a two-way connection to target CDP node. So for this, one IO port was added, and this will be fetching out the server object nodes data. And one CDP port was also added to this OPC-UA server, and it was called as address port. So we also need to show the node space addressing to the HMI, to the user who is connected to it, so that he can see, okay, like from which server nodes he is reading, or from which server node he is writing the data. So this was a concept for OPC-UA server. And after that, for MQTT, MQTT is also a protocol. And in MQTT, we defined topics. So, so for defining the topics, like when you add any MQTT client component to your library, you can define any published topic, and you can also define any subscribed topic as well. So over here, there were different published topics, and there were different subscribed topics on the basis of the uh, from whether the client wants to read it, or whether the client wants to write it. So different topics and were added, and these topics have some way of you know passing the information. So, and in MQTT, the information is transferred to the broker or to the subscribing client in the form of topics, and these topics have some specific uh, way of representation. So over here, the topics uh, were named according to the standards, and one IO port was added over here as well. And these topics, this one IO port was for fetching out the MQTT client data and providing to any subscriber. And one address port was added inside it as well to fetch out the topics strings so that it can be displayed on the HMI as well. And one more thing over here was like we whenever we have the MQTT client component inside our application, so we have to connect to the broker host or the broker and the broker port. So these are uh, for broker host, we just connected it, given it a value of this, so that it will be a loop interface. So just for the testing purposes only. And for Modbus, in case of Modbus, the data is transferred in the form of packets. And whenever we just add some Modbus component in our system, so we have to define the packets, like how the packets are defined, and what will be the function codes, and in Modbus, uh, the the addressing space model is like registers, coils. So as we have like in our HMI, we are reading different values which are not discrete. So we have to define slave packets accordingly. So wherever we add Modbus slave component to our app and to our library, so we have to add Modbus slave packet as well. And this slave packet will also contain the data, and we have to define over here as well, like the IO module. Like over here, we have to add IO module. IO modules is used by some IO servers, like in Modbus specifically, to hold the data and to send the data to the receiver. The CDP signals in the IO modules make up the data, typically in the order and size they are accepted. So we added the data on the basis of whether we are going to read the register or whether we are going to write the register. And over here, we have also set like we have to differentiate it. Otherwise, it will be an error, because if we in the holding registers, these registers are 16 bits, and if we set it to the same value, so it will be like at the same time, the Modbus will be reading from it as well and writing out from it as well. So it will be like a clash. So so in Modbus we also define some function codes, whether we are going to read the data or to write the data or from the into the coils. Coils are like 1 bits only. So consider of it as a on-off switch, and we are just connecting it to the remote. So over here we can define the function code as well. Read write multiple register, and read write multiple register is like at the same times we are reading and we are writing from the registers as well. So it will be like less time consuming and more beneficial. So for this, there was also a IO port added, and there was also a address port added as well. So this IO port was fetching out the slave packet data and providing it to the HMI or the user. And at the same time, this address port is fetching out the holding register addresses and giving this holding register addresses to the user. So this was the all the routing scenarios as well. And after this, so we have to over here we had to give the possibility of switching the protocol if if any user wants to switch between the MQTT client, MODBUS, or OPC-UA server. So we had to add port mux, and in CDP Studio or a port mux component is a component which is used to, you know, fetch out a lot, take in a lot of ports, and it also has one index signal as well. So from every OPC UA server, we have added two ports as well. One IO port is for fetching out the data from the Modbus for Modbus slave packets, and one address port is fetching out the data about the holding registers. And in case of MQTT client, one address is IO port is fetching out the data about the topics, and one uh, about the topics payload, sorry. And for one address port is fetching out the topics strings like over here. So over here address port, we have also added that relative routing. So there is a concept like one is if one is giving this signal, so you can set the relative routing over here as well. So after that, this was the uh, port mux for the switching of the data. Like if user is selecting index, changing the signals index 0. So at that time, this output port, which will be connected to this. So after that, this this CDP port data will be fetched out from IO port 1 to IO out port. So it will be like you can switch from the ports data through the use of port mux. And one address port mux was also added over here, which was used to for the switching of the addresses, relative addressing. Like if one user is selecting the port, the index value over here, then at the same times, because of the relative routing, this index value of the port mux will also change. So if our HMI is connected with the, like I will show you, like over here. So if index 1 is connected, tank interface 1 is connected, and the user wants to switch. So he will have the data according to the uh, required protocol. Okay, after that, yeah, this was the case, and this was just the library, and after that, we have to build it. So it will the build process is on the like Qt, I think so. Yeah. And after that, we created a process tank simulator app, and this app we also added a process tank component, and this component contains this component in this component 100 tank interface from this library were added. Like if you create any library, then your code block will be generated over here, so you can reuse it for any future purposes as well. So as we had used build our tank interface library, so this tank interface library will contain 3 IO servers for MODBUS, MQTT, and OPC-UA as well. And they will also contain all the tank simulator code functionality as well. So I already explained about that as well. So in the design mode, the purpose was to develop an HMI in which the user can select the queuing value, and he can change the row value as well. And after that, he can also adjust the queue out, flow out valve coefficient as well. Then on the end, he can choose from the list of the tank interfaces and select the IO selector. On the basis of that, he will be able to adjust the to see the output values of the P1 tank area, tank volume. P1 is the pressure inside the tank, and fluid height is the fluid level changing on the basis of the Q in and Q out, and the Q out over here will be also calculated on the basis of CP. So when we just build it, and like over here we can just run and connect. So it is already connected, so I just want to give it give the demo. And after that, okay, yeah, all these hundreds of IO servers are running, and what does it mean? Like they are ready to provide services to any number of clients. So the number of clients can be 100 as well, and they can be remote as well. How we did it as well, like over here, if you select your process tank, and you can deploy it to any user as well on the basis of the addresses. And but for over here, I just selected Wi-Fi. So any user who will be connected to the same internet, uh, he will be able to have this in his web UI. And how to create a web UI over here, you just add new. So the web UI will be created. So when I just run and connect it, it is already running. And for the testing purposes, if I go inside this, and if I say tank interface 3, I am selecting tank interface 3, and I want to see, okay, tank interface 3 is selected from here, and I want to set in the IO selector over here, OPC-UA. So OPC, I want to check like whether OPC-UA is selected or not. So from the address port marks, I can see over here. So this IO selector is giving signal to this index value to set it to 2. So it will be then when we set it to 2, so that this port is connected to the OPC-UA server. So the client can talk with this server. So what does it mean? Like you can change the value of the QN, and on the basis of that, you can have the fluid height changing over here as well. So if you select the CB or the flow out coefficient over here as well, if I adjust it to 60, so on the basis of that, the fluid height is also decreasing. And if I want to switch the protocol, then I can also switch it from here as well. So over here, the same changing can be seen over here as well. Like now it is also giving us this is like our control component, and these are our communication methods, and these are our clients who wants to talk with our control component as well. So this was just for this demo, and if I want to switch this, if I want to see it in web, so what we have to do over here was okay, CDP Studio also provides to convert your already made HMI to web UI as well. So for this, if we go over here and table editor, and over here web URL, you just have to select this, and it will open the web URL over here as well. So you can have this same HMI in front of you. So for this, okay, like now I'm connected with web UI, web HMI, you can say. So over here, I can talk with the servers already deployed on my CDP application. So the servers can be OPC-UA as well, OPC and MODBUS as well, and one more as well. So in this case, suppose I'm connected with this tank interface 12. So I want to see like what kind of changing it is doing. Tank interface 2. So over here, I want to see tank interface. Oh, this is the one. Tank interface 12. And tank interface 12 is selected. And over here, if I want to adjust the value, and on the basis of that, I can see the fluid height over here as well. So this client is connected with the OPC-UA server over here. So and if there is any remote client who also have the access of this HMI through this web URL, so he can also talk with this control component through the use of the file servers. So like at current, I am using the same web UI to my other computer, and this computer is also connected to the same network. So if I will choose over here 9, and in my second computer I'm choosing 9 as well. So if I want to change it, so I can see the adjustment over here as well. But we can also, put some security over here as well, like in the real world scenario, like if one user is connected with any remote facility tank, and he wants to adjust the parameters, and he on the basis of that he wants to see the output of the control on his HMI. So any other users cannot interchange or intervene in it. So different protocol provide different kind of security and user authentication as well. So it can be also implemented in this well as well. But it was just for the testing purposes. So yeah. And one more thing over here was because we have built like 100 servers over here as well, and to have them differentiate from each other so that there will be no uh, networking problem. So we have to add for OPC-UA different. We can change the namespace index of them as well, and we have to change the port numbers and IP addresses as well. And for this purpose, like over here, when you are connected, when you build it, so these tank interface components at the backend, they are built in their XML file. So CDP Studio provides an XML CDP Python API. So you can change the objects and properties of these as well. So through the CDP Python configured API. So I have also used this. So I just changed all of the port numbers, and in case of OPC-UA, and for MQTT, the topic names, and for MODBUS, the holding register values. So yeah, this was the case, and yeah, this was a demo, and thank you.